Okay, we've got a oil sample back here from the 2001 Ford Focus, and we changed out 5 quarts of oil. It had been running the Turbo Maxx product in it for nearly 3 years. This is a sample sent in from a customer, and this is the sample that was sent from the crankcase. It was taken on a cold, snowy day, so under cold conditions, so it had a little bit of water in it. And these are the results. Here's the test numbers. It had a critical area in silicon and potassium, but the additives that we have actually add silicon and potassium to the oil as a part of the additive package, and all this says is those are higher than the normal ASTM ratings allowed to be in the SM formulation of motor oil. So it's not an indicator. Sometimes it's an indicator that there's a leaky head gasket, but since this customer added no water over 3 years, a period, it could not be a leaky head gasket. It's just those are the right numbers for adding our product in. This sample was, let's see if I can find it on the sheet here, taken, well, it was received in January of 2016 and completed on January 22nd of 2016. And this oil had run 55,000 plus miles and only used a couple quarts of oil. And you can see here, these are our wear parts. These are based on parts per million of particles found in the oil, and the testing is based on the recommended oil change intervals of 3,000 miles. So you can see here that the iron is at 54 parts per million. Generally, we see cars that are between 15 and 30 parts per million at just 3,000 miles, and they're not even in the green level, so it's below, for that car, it's below its acceptable range, which is very good. And we can go across the line here, and you can see all of the numbers for your own selves, what Turbo Maxx actually does for this. The zinc and phosphor numbers are higher than standard limits, which are 800 parts per million, and we intentionally raised those a slight bit, but with still within the standards for use with on a 2001 car, but they're higher than the actual recommended. And then this is what's really amazing over here. You have the really low wear parts per million, but you look at the nitration numbers and the oxidization numbers, those numbers are still better than brand new synthetic oil. The base acid number, if the numbers were 2.77, that would be low, which means it's getting low on calcium and magnesium to resist the acid. But after 50 some thousand miles, that is absolutely outstanding. That's just slightly below the 3,000 mile number. It's not even in the, it's still in the beginning of abnormally low. And as you can see, it had a little bit of water in it, and that comes from taking a cold sample, not warming the engine up. Had a little bit of fuel dilution in it, which you could smell in the oil, which after 55,000 miles and only having a 4.5 to 5 quart system would be pretty well normal. And you can see over here that the oil was actually time on unit 3 years, and it was 55,161 miles on a single oil change. I don't know of any other oil product out there, any place on the entire planet, that will do what this does. Those wear particle numbers are absolutely, I mean, that's like zero wear in in that amount of time. That's almost uncomprehendable how low that is. That right there is what saves you money. That's what keeps your cars on the road, right there. No acid buildup, no sludge buildup. Viscosity is still in the normal range at 55,000 miles. At the viscosity at 100 C, the Senna-Stokes is at 9.8. So it's still a 5W30 all the way 55,000 miles down the road. And all those numbers you got right there. The calcium, which is at 1830, which is the calcium and magnesium, which is what keeps help the engine stay clean. Boron keeps things lubricated and from sticking. Potassium works as well in that. And there's many other chemicals that we put in, 14 other ingredients that are not listed on this page that they don't check for, but that's what makes our product different than everyone else's. Every single aspect of oil will stop the problems. In some cases, like in the Ford Power Stroke and in the Duramaxes, the stiction problems absolutely eliminated immediately. And we're going to post this on YouTube for everyone to see. Thanks. You can get this product at zddpmaxx.com. It can be found on Amazon and eBay as well. It's Turbo Maxx oil additive. We have a very fantastic fuel additive that is the Turbo Maxx C4, which this car also runs. It reduces the wear on the gasoline side or the diesel side of the combustion process. Has special lubricants in it to keep your engine valves, keep those parts of metal and dirt and sludge and everything completely under control. This little car gets almost 41 miles to the gallon, and it's got well over 200,000 miles on it, and only been serviced once in 55,000 miles. We hope to hear from y'all soon. In the oven at 500 degrees to kill it. Now we're doing a burning test on it right now. I got 500 pounds of weight at the bearing and took the oil bath away to see. This is the oil that's been used, cooked at 500 degrees for an hour in a closed vessel. You can see how black it is, and we're running with no oil bath at all. Definitely stinks. You can look and see that as long as that oil bead stays on there, because it's attracted, some of the chemicals that are in there are attracted to the metal, and it's drawn to the heat. And some people thought that once our product got hot, it would lose its ability, because some of the products use chlorinated paraffin. If they don't run a buffer in it, as soon as it gets 180 degrees, it turns to hydrochloric acid. Wanted to prove that our product does not turn to hydrochloric acid and a corrosive, which is the same as a cutting fluid. So, under severe conditions, the most severe, you're never going to get your oil to 500 degrees. You still see that little tiny bead. Can you see it on the camera there? Just one little tiny ball rolling around on there. Normally with just fresh oil, this will go with this test about 4.5 minutes with no oil whatsoever. And actually the smell that you smell is the same thing. It's like in burnt gear. That's the sulfur that's cooked. It's been over temperature, why it stinks so bad. What happens if you ran that in your gear and you have a little bit of a problem, or you want to a real low fluid weight, you can run low fluid weight because your film doesn't go away. It's the film that does all the work. It's the fluid that carries the temperature away. And as it gets hot, it's evaporating the oil. Right now we're at 2 minutes and 35 seconds. Besides, before we decided to start adding it. Nope. It'll just completely dry up. You can see it's still got quite a bit of oil on it. So we'll go, I don't know how much longer it'll go. But once it starts to take off though, once the bearing surface gets so hot that it cooks it out of there, it goes fast. A little shaky here. Quite a bit of smoke. So the actual bearing load that's on there, it's like, since the bearing width and the load that's on there, if that's at 500 pounds, it's at a 90 to 1 pounds per square inch, because it's only a tenth of an inch wide, or 10 thousandths wide. So that's at like 5,000, no, 45,000. It's about 40,000 pounds of load per square inch on that bearing surface, which is not uncommon because a camshaft on a flat tappet cam will see 100,000 pounds of load at maximum, per square inch. A rear gear can see 200,000 pounds per square inch because it's a 90-degree angle. That's why your gear oil, since it doesn't come in contact with combustion, they can use a lot more sulfur in it. That's what makes it stink, the phosphor and sulfur. You see, it's really beginning to cook there. We're at 4 minutes and 43 seconds on oil that's been at 500 degrees for an hour in a pressure vessel. Tried to coke it, turn it to carbon to varnish, same thing that causes sludge in your motor. Pretty impressive or what? The motor oil won't do this at all. The racing oil that we have here it'll do that for about 30 seconds. Huh? Well, that's because that's probably because they have an interference problem, or they have an exhaust. Exhaust will cause that to stink like that because if it's leaking combustion into it, it kills the oil. It's excessive heat from something, did it burn the bearings out of it? Well, it could be a couple different things. The clearances are wrong on the bearings for the oil they use. If it has tight clearance bearings and you run a heavyweight oil, it'll burn up. Oh, there it goes. That's 5 minutes and 51 seconds. It's probably actually about almost 6 minutes.
That's about 7 minutes.
Yeah, that's outstanding.